Hi, this is Stuart Bruce from Washington College. I'm going to give a demonstration of Module C in our GT30 course on Spatial Analyst. For this module, we're going to learn how to use the kernel density, line density, and point density tools. Now to get started, you're going to need to navigate an ARC catalog here. Go ahead and find your data for Introduction to Spatial Analyst. In the Shapefiles folder, there's a folder called Students Shape. I'm going to go ahead and grab that file and bring that over. And we're going to get a bunch of dots. Then we're going to go ahead and use an online base map. Go up to Add Data. We'll click that. We're going to add base map. And we're simply going to add the super simple streets base map to our map. So our project here, we've been asked to create a density map so we can determine where the highest concentrations of students are in this area. To do that, we're going to open ARC Toolbox, Spatial Analyst Tools, go to the Density Tool drawer, and we'll open the Kernel Density tool. So I pop open my ARC Toolbox again, go to Spatial Analyst. I'm going to go to the Density Tool drawer. I'm going to go ahead and open up Kernel Density. All right, so what we're going to do here, we go ahead and drag the student point file into our input point or pylon features. We don't have a population field for this. We actually have 1 dot per student, even if there's 10 students living in the same house. We're going to set our output raster to be in our exercise data folder, students.tiff, so that we know it's going to be a raster image. Now, the default output cell size is 196, and if you recall from my lecture, typically I would take that in half. So I'm going to go ahead and type in 100. The area units here are going to be square miles. We're not going to mess with the search radius, and we're going to leave everything else the same, and we're going to go ahead and click OK. All right, now when I processed that at the conclusion, I got one of these yellow caution signs. And if you go up to the geoprocessing pull-down window, you can open up the results dialog. In the results dialog, if you go into your current session, then you'll see that little yellow error that I got. When I open up the messages, it was basically warning me that a couple of the features were skipped because they had a null or empty geometry. Not something we really have to worry about right now because it certainly looks like the tool functioned properly. I suggest you go ahead and turn off the students now, and I can get rid of the results window over here. And right away you can sort of see where the highest concentrations of students are. And in the legend here, we've got a bunch of numbers. And the question you might be asking yourself is, what do all those numbers mean? Well, before I explain what the numbers mean, we're going to go ahead and sort of reclassify how this density map looks. So go ahead and open up the Symbology tab. And in the Symbology tab, we are going to change the number of classes to 4. This is sort of a standard way that we do density maps. If you unclick the color here in the color ramp to go to the text view, one of the nicer ways to look at data is to use the condition number color ramp scale. And then typically what I would do is I would change the low end value here, 0 to 207, to no color. Now I click OK. And now I kind of have what you might recognize as a typical hotspot map. Now when I look at the numbers in the legend, they're kind of really ending at some really odd values. So I'm going to try to clean this up just a little bit. I go back into Symbology, and here I'm going to go ahead and change the range values. So the simplest way to do that is to click the Classify button, and then over here where the break values are, just come in here. I'm going to make my first break value 200. My next break value is going to be 400, and my third break value is going to be 600. I really can't do anything about the last value because that represents the highest number in the classification range. Go ahead and click OK, and now you can see it looks a lot neater. Notice over here in the label, though, I have a lot of extra decimal places, which I really don't need. So if I right-click on the word label right above those, or left-click, excuse me, I can click Format Labels, and I can go ahead and get rid of all but one of the significant digits past the decimal place. So I click OK. Now you see I really cleaned up my legend. Only problem is I might have cleaned it up a little bit too much. So I have to go back, format labels, and maybe I need to have a couple significant digits there. Click OK. I want to try to basically get past the, there we go, 201 to 400, 401 to 600. That actually now makes sense. Go ahead and you have to reset the 0 to 200 range to no color. And go ahead and click OK. And now I have a nice legend, looks nice and neat, but I'm still not really sure what those numbers mean. So basically what those numbers mean, if you remember, we set the units to square miles. So really the way that the density tool works is that it goes to each pixel, and within a square mile it counts how many points are there. So at the densest area, which would be right here, within 1 square mile of the center of that, we have almost 828 students. And you could come in here and play around with it a little bit to see, but if you kind of zoom in, and then you could actually draw a box if you wanted to. Take a second here to draw. Then if I turn the student dots on, so a square mile from this area here, we could pull the measuring tool if we wanted to look at it, but that's really how the density tool works. Now just to prove that to you, if I go back and run the density tool again, which is what I want you to do, run the kernel density tool again, but this time change the area units to acres, and you'll see the numbers will be much, much smaller. So go ahead and try that, and we'll see what it looks like. So after you run that tool, you can look at the legend, and basically what it's telling you, at the densest area, we have a concentration of about 1.15 to 1.29 students per acre. You don't have to bother with fixing the legend like you did before. Now, for your map assignment number 4, we want you to go ahead and make a map. You can either use the one you already did, you could fix the acres here, but go ahead and make a map showing the area, and it's going to be suitable for presentation to the school board. All right, next we're going to learn how to use the line density tool, and what we're going to do is we're going to do a line density analysis of state roads in York County and determine if we can check out where the Pennsylvania State Police should patrol in order to set up checkpoints. So you're going to go ahead and close this map document and open up a new map document. Now, with your new map document open, we're going to go ahead and inside our exercise data, under Shapefiles, PA County 2008-01, we're going to drag the PennDOT state roads to our map view. Now, we're going to explore what attributes we might be able to use to do a line density analysis. Go ahead and open up the attribute table for PennDOT state roads, and put this here where you can see it. And what we're looking for is a layer or a column called CUR_AADT. So I believe that means current average or average annual daily traffic. And this is basically giving us the number of cars that are traveling on that road through a year. All right, our next step here will be to go ahead and open up the line density tool. So over in our ARC toolbox under density, you'll see line density. Go ahead and open that tool up. And what we're going to do here is we're going to take and drag our PennDOT state roads as our input polyline feature. Now, this is a good example. We do have a population field that we're going to use. So we're going to use that current AADT. So we have to hit the drop-down menu here. There it is. We're going to go ahead and select that. Go ahead and set your output raster to be, let's see, what are we going to call it here? All right, so call your output raster York _AADT.TIF. If I put a wrong thing in there, click save. Now in this case, we're going to go ahead and leave the output cell size alone. And the search radius, we're just going to leave at the setting that it is at as well. And go ahead and click OK to execute the tool. All right, well, when we look at our numbers here, we definitely can see which roads have the highest amount of traffic. This one road here is actually Interstate 83. This is Route 30. So it actually makes kind of sense. These areas over here where we have major intersections, you'll see a little bit more concentration or more density. If we look at our numbers are just huge. Our top numbers are up in over 6 million. Now the issue here is that the PennDOT state roads, if we open that up and look at properties, they are actually set to be a NAD 83 geo, so the angular unit's in degrees. If we want to get actually any meaningful numbers here, we're going to have to reproject this data into something with, like a state plane projection or something like that to actually get. Now I'm going to not do that just to save some time in the lecture. The slides and the lessons, basically tells you exactly what to do. Go ahead and reproject the tool. Once you've done the reprojection, rerun the tool, look at the data, you should come up with some numbers that look a little bit more reasonable. I will point out that this overall analysis is not really complete because it doesn't include the local roads, but unfortunately the PennDOT local road file didn't include AADT data, so you really can't do that to your analysis. Now to go ahead and finish up this section of Module C, you do have a map assignment.